Thank you very much, George. Thank you very much for attending. Good morning and good afternoon to everyone. So this paper that I'm going to present today is a joint work with Lucia Sbaglia. She's at Durham University in the UK. And so the paper that I'm about to present is about product differentiation. In particular, we will be assuming that we have two types of goods. On the one hand, we have green good, which is produced with low emissions per unit of output. We have, on the other hand, the brown goods with high emissions per unit of output. We will consider that consumers are willing to pay a premium price for the green good. And in this framework, we will give three different definitions of what we consider being a green frame. So we have three definitions. We will compare them to see which one of the definition will give us in the end the best outcome. These green firms, they are competing à la Cournot against the brown firms, and they also play a dynamic stock pollution game. So on top of that, we assume that the firms can shift between behaving green or behaving brown or vice versa. So the two research questions that we have is, so we could have three different market compositions. We could have only brown firms, only green firms, or a mix between brown and green firms. And the question is, under which conditions do we have one stable market composition or the other? And the second research question is, for each one of these market compositions, the question is, which of these different definitions of being green performs better in terms of the environment or in terms of the economy? And to answer this question, we will be looking at four different dimensions. How many green firms do we have in its definition of being green? This is the number of green firms. How large is the pollution stock? How big is the consumer surplus? And finally, this is a mix between the consumer part and the environmental part. This is the consumer surplus per unit of pollution. So our paper is not placed with the green and brown consumers literature, but we will focus on the production side. So we will have our paper placed in this product differentiation literature. We can talk first on this the paper by Sang and Vives, where they define the differentiated duopoly. We will be using their utility function, and this differentiated duopoly is used in several papers. For example, in Conrad in 2005, there's this spatial duopoly model, like in hoteling, and in this case, they consider that consumers are environmentally concerned. Also, the duopoly market is analyzed, this differentiated duopoly market is analyzed in Coppel and Brand within a corporate social responsibility model. And more particularly, from an environmental viewpoint, Liu, Wang, and Li, they focus on environmental corporate social responsibility, again, as a differentiated duopoly market. So finally, Lucia and Michelle in 2021, they moved from a duopoly to an oligopoly, and then there is free entry in this model. In our formulation, we will consider not an oligopoly, but very many different firms that may behave as green or brown firms. So following Sang and Vives, we considered the utility of a representative consumer as given by the consumption of the green product and the brown product. So there is, let's say, we are assuming, let's say, homogeneous consumers. They have a taste for variety, so they like consuming both type of goods. In this utility function, it is important to point out the the parameter capital S, which defines the degree of substitutability. If S is close to capital F, then we say that our market is more and more homogeneous. So the two goods become closer to perfect substitutes. So the idea is that consumers perceive the two goods as very similar. Conversely, if S goes to 0, if S becomes smaller, then we are going to the case of independent goods. So we are not analyzing complementarity here, which could require negative values of capital S. So with this in mind, as I said, we have very many films. Let's say there is a large number of films within this 101 unit interval. And of these films, N will produce following a green technology, and 1 minus N will follow a brown technology. So the thing is that N is the share of green films in this unit interval, although I will refer to them as the number of green films. And 1 minus N is the number of brown films. So the total amount of green production will be the number of green films times the quantity produced by each green film, and the same thing for the total amount of brown production. So from this utility function, it's immediate to obtain the inverse dynamic function for the brown and the green product. So for this two demand function, we will be making the assumption that the choke of price for the green product is higher than the choke of price for the brown product, meaning that there is a premium price paid for the green product. A green is the willingness to pay for this green product above the willingness to pay for the brown, but for shortness, I will refer to it as the premium price. On top of that, we need to assume that S is smaller than capital F just to have a concave utility function. And also because these demand functions are linear, in order to have positive quantities and prices, we need this premium price. This premium price has to be large enough, but not too large. Because if it was larger than F over S, then the brown producer, they will be producing negative quantities. So basically, our assumption is that the premium price is greater than 1, but smaller than this upper bound for feasibility reasons. So with this in mind, let me introduce the different films that we have. The brown films, they produce using a quadratic production cost. They emit alpha B units of pollution per unit of output, and they are also facing a linear damage from pollution. By the way, you can, if you can ask any question, you can stop me anytime. On the other hand, the green producer, they have to pay a more expensive cost. So this W is larger than 1, and it represents the cost disadvantage of producing green. On the other hand, this green technology is more efficient in terms of emissions per unit of output. So the emissions per unit of output are lower in the green than in the brown films. But the pollution damage faced by the green films are exactly the same as the pollution damage faced by brown films. As for the dynamic of the pollution stock, we made the standard assumption. The evolution of the pollution stock is given by the green emissions plus the brown emissions and minus the decay, the natural decay of pollution, which is delta minus delta. So the brown films, they have to decide the total the amount of production in order to maximize the discounted profit across time, discounted at rate R. However, we will be assuming that these are atomistic agents, so they are myopic price taker agents. And on top of that, we assume that they disregard the effect of their decisions on the evolution of the pollution stock, meaning that these agents are actually static players and they just maximize the instantaneous profits. As for the green films, we will distinguish 3 different types of green films, as I said at the beginning. First, I will define the green technology films. And these films are basically, they behave basically the same as the brown film. The only difference is that, well, they have to pay an extra cost because they produce using this green technology, but in exchange, they get, they get a higher price because the consumers are willing to pay a higher price for the green product than for the brown product. However, they again, likewise as the brown films, they disregard how they are affecting the evolution of pollution, and therefore, again, these films are static players. They just maximize instantaneous profits. So this is the first definition of being green. You just have a more expensive cost, but you get, in exchange, you get a higher price because the consumers are willing to pay a higher price for the green product. The second definition of being green is what we call a green cartel. So let's assume that the films that behave green, they join together and they collude to exert market power. So they form a cartel, knowing the demand for the green product. They try to manipulate the price. They accept this market power. So the difference with the previous case is that they are not price taker, but they accept this market power. But again, these agents, they take the level of emission as given. They do not acknowledge that they are affecting the evolution of pollution. And so again, the green cartel is composed by static agents. So both the green technology case and the green cartel are static agents, which leads to the third and last definition of being green, which is the club. In the club, we assume that the cartel still has this market power. They still know the demand for the green product. But on top of that, we assume that they acknowledge that their production decisions will determine the accumulation of pollution, which will affect their future welfare. So these agents are really dynamic agents. That's why we use the letter capital F to denote this green club, because these are far-sighted players. So what we have in the club that we didn't have before is that the club is formed by environmentally concerned firms. So for the green technology, we're assuming that the brown films and the green films, they just determine the optimal supply as a function of the prices and taking into account the cost. Remember that W is the incremental cost for producing using a green technology. If we confront the optimal supply with the demand for brown and green production, we can get the optimal quantities and prices. But notice that both the optimal supply and the demand for these goods, they do not depend on the pollution stock. And therefore, the quantities and the prices are independent of the pollution stock. Of course, they depend on how many green films do we have in the economy, but they do not depend on the stock of pollution. What we allow is the green film to switch from green to brown production or vice versa. So in order to compute the equilibrium market composition, the value of N, we have to determine which is the number of green film at which the profit from behaving brown exactly equals the profit that one would get if you switch to a green technology. So notice that the damage from pollution is the same for brown as for green technology, and therefore the pollution exits from this equation. And this equation can be written as a second degree polynomial equal to 0. And this second degree polynomial has a unique stable root, which again, let me repeat, it is not dependent on the pollution stuff. So we can compute, actually we can compute it analytically, the equilibrium market composition in the case of green technology. So on the same tool, we can go to the green cartel, and the difference is in the quantity. In the case of the green tech, we had this price divided by C over W. Now, the cartel takes into account the demand for the green product, and then they determine a smaller production than in the case of the green technology. So again, taking into account the optimal supply by brown and green producers and the demand for the brown production, we again can obtain the optimal quantities and prices. And likewise as before, these quantities are again independent on the pollution stock. Remember that both the green tech and the cartel, we are dealing with the static agents. So again, the equilibrium market composition is composed, is computed for the value at which the profits and that the brown films obtain, the instantaneous profits that the brown films obtain equal the profits obtained by the green films. And again, the damage from pollution being the same disappears from the equation. The only difference is that now we have a third degree polynomial in N, but again, there is a unique stable root that determines the equilibrium market composition for the cat. Finally, the third definition of being green is the club. So assume that at a given point in time, let's assume that we fix the number of green producers given by N. So the optimal supply by the brown producers is the same as in all the two other situations. But for the green films, now we have a really dynamic problem. Remember now, this club acknowledges that they are affecting the evolution of pollution, and therefore assuming that N is fixed, if the number of green fixed from a given time t on remains constant, then we can solve this optimization problem, which is given by the flow of instantaneous profits discounted at time r, taking into account the inverse demand function for the green production and the dynamics of the pollution stock. So for this problem to be solved, we need to solve the Hamilton-Jacobi-Bergman equation that we state here. And the idea is the solution to this Hamilton-Jacobi-Bergman equation, taking into account that we're dealing with linear state differential again, will be an optimal quantity which is not dependent, which is constant, which is independent of the stock of pollution. So we can obtain the optimal quantities and prices again, which are not dependent on the pollution stock. We can compute the pollution stock at the steady state and the optimal path of the pollution stock across time. But again, remember that we have assumed that the solution to this game is under the assumption that we are considering that N is fixed across time. Now we have to compute what is the equilibrium value of this N, which will be the value at which the value function for the brown films equate the value function of the green films. But again, these value functions are linear, because remember we're dealing with a linear state dynamic again, and therefore these value functions are, well, they are not only linear, but the linear term both for green and for brown are exactly the same. So that now again, if we want to compute when these two value functions are equal, we just need to compute when the constant term, the term which does not depend on pollution, equates for the two definitions of brown and green. So this expression can be written as this ratio, and the numerator, well, the denominator is positive. So the question is when this numerator is equal to 0. But now this numerator is fifth degree polynomial, and now we cannot solve it analytically. We cannot determine which is the stable root analytically. Actually, we have 3 stable roots, although we can see that at most there is one stable root within the 0-1 interval within which we need N to be. So this is chosen numerically. In the case of the club, we will be analyzing this third scenario numerically. So For the green tech case, let me briefly comment on this case, because this is the case in which we can analytically solve the problem, and we can actually have some information on the effect of parameters on the solution. So if this capital S was the substitutability coefficient, if this is not too low, not too high, I will go to this in a minute, then we can compute the equilibrium market composition, which will be, if the premium price is small, no one wants to be green. If the premium price is very large, everyone wants to be green. And when the premium price lies within these two bounds, then we have the mixed market. There is an expression, it is simple but not interesting, to determine what is the market equilibrium in this case. Once we have the market equilibrium, the number of green firms that we have in the case of green tech, we can also compute what is the pollution stock at the steady state, what is the consumer surplus for this case, and this definition, which takes into account both the economic and the environmental variables. This is the consumer surplus per unit of pollution. So these four variables will be the variables that we will be comparing for the three definitions of being green. And in this particular case of with green technology firms, we can analytically, we can compute what is the effect of the main parameters on these variables. And as for the premium price, for the willingness to pay for the green product, the higher the premium, the higher, of course, is the number of green firms. Therefore, the lower is the pollution stock. But the effect on the consumer surplus is U-shaped. So if the premium is initially small, an increment in the premium will increase the number of green firms and reduce the number of brown firms. But because green firms, they produce less, this will reduce the consumer surplus. However, as this premium price increases, once the premium price is very large, increments in this premium price will rise the size of the market, increasing production and therefore increasing the consumer surplus as well. As for the consumer surplus per unit of pollution, it is also U-shaped. I have written here an interrogation mark because this is not analytically seen. I can tell you it is U-shaped because I have seen it numerically. This is analytically shown. Also, an important parameter in our analysis is alpha green. Remember, this is how effective is the green technology. So the smaller is this alpha, the emissions per unit of pollution, the more effective is the technology. Interestingly, this effectiveness has no effect on the number of green firms, nor on the consumer surplus, because it has no effect on the market. It only affects how the production translates into pollution. So the more effective this green technology, the smaller is the pollution stock, and therefore the larger is the consumer surplus per unit of pollution. Another important parameter in our model is W, which represents the cost disadvantage of producing green. We can also compute its effect on all these variables, well, almost all these variables, but the effect is very cumbersome to explain, so I would prefer to present it later with the graphs. So regarding this first proposition, I can present it this proposition graphically. In the horizontal axis, I have here the substitutability coefficient. In the vertical axis, the premium. So if A green is larger than A brown, we have a premium once we are above 1. So if we have a substitutability parameter between these two bounds, then we could have, if the premium is low, no one wants to be green. If the premium is very large, everyone wants to be green. And in between, we have a mixed market. Notice that the size of this region, the size of this interval decreases with the substitutability parameter. So the greater the substitutability, the shorter is this, the narrower is this interval. If we are to the left of this lower bound, then there is no room for the for this scenario in which we have only brown films. We could have, even for the slightest premium price, we already have green films, and we could have only green films if the premium price is very large. But we do not have the case with only brown films. And if the substitutability, if the substitutability parameter is very large, then we have a problem, because this blue region up here corresponds to the region where the brown producer will be producing negative quantities. So this is not feasible. And so we will not analyze this part of the graph. We will not analyze this part of the graph. We will focus on this intermediate case. Because again, we have brown, mixed, or green market. And this same graph can be done. This is for the green tech films. We can do the same for the cartel, and exactly the same for the club. These three graphs are similar, but they are not the same. The lower bound is the same for the three definitions of being green, but not the upper bound. This blue line here is different for each definition of being green, and therefore the upper bound for the substitutability parameter is different for the three definitions, and the smallest is in this case of the club. So we will be assuming that S lies between the lower bound, which is the same for the three definitions, and the minimum of these three, which is the case of the club. So from now on, I will be assuming that substitutability lies within this region. But then again, we have three possibilities: brown, only brown films; mixed market, only green. Under this assumption, we will have only brown, all films are brown, if the premium is sufficiently small, if the premium is below this red line. We would have only green if the premium price is above the upper bound, which is this expression for the green tech, a bigger expression for the cartel, and a less nice expression for the club. But we have all of them analytically computed. So we have only brown films for low premium price, only green films for a large premium price, and in between we have the mixed market. So I will present now the comparison of the three definitions of being green. First, in the case of only brown films, then in the case of only green films, and finally, when we have a mixed market for the three definitions of being green, meaning that A green lies between L and the minimum of these three upper bounds. So what I will be analyzing is what happened here, because in this region, well, under some definition, we will have a mixed market, but under a different definition, we will be in a green market. So this is very messy to compare. So if we are in the brown, if we're in the case of a brown market for the three definitions, there is not much to say. If the premium is low, everyone is brown and is zero, but all brown films are the same everywhere. So everything is the same for the three definitions that we are implementing. If we move now to the case of a green market, if the premium price is very large, if the premium price is larger than the maximum of the three upper bounds, then everyone is green. And if everyone is green, what matters is the type of green. For the pollution stock, the definition that gives the smallest pollution stock would be the club, because in the club, the green films internalize the environmental problem. So that's why here, when everyone is green, the best option is to have a club. However, for the consumer surplus, if everyone is green, the best is to have the green tech films. It makes sense because in the case of the green tech, we don't have market power, while for the cartel and the club, we have market power. So we have the highest consumer surplus for the green tech. And more interestingly, not only in terms of green tech, but in terms of, in terms of the consumer surplus, but in terms of the consumer surplus per unit of pollution, green technology is also the best in this case. So basically what this says is, if you accept this as the definition, which combines both the consumption part and the environmental part, then if everyone is green, if the premium price is large enough, then the best thing is to have green tech firms. So it is the best to have firms who does not care for the environment. This is what this would say in the case of a green market. So, but finally, the question is, so what happened in between? What happened when we have a mixed market? So the idea is that the premium lies within the lowest and the minimum of the three upper bounds. So in this region here, what I'm presenting now is how the different definitions of being green compare across this interval here. So let me, as an example, explain a little bit this, this graph here. Assume that the three upper bounds are ranked as in this way. So this means that for the green tech, we can reach the green market for the smallest premium price. Then it will be the cartel, and finally the club. So if this graph is correct, what this says is, if the green tech is the definition that reaches the green market for a smallest, for a lowest premium price, then what you will see is that the number of green firms is higher across the whole interval in which we have a mixed market. It is higher than the number of green firms in the case of a cartel, which is larger than the number of green firms in the case of the club. So this is not necessarily true, because we could see crossing in this part of the interval. So what I will present from now on is what is happening across all this period, all this interval here. But because we have many cases and we have to compare three different definitions of being green, what I will put the emphasis is which one gives the best, which one gives us the highest amount of, the highest number of green firms, the lowest pollution stock, the highest consumer surplus, etc. But before that, let me first focus on this ranking, because I have written here that the rankings is green tech, cartel, and finally the club, but this is not necessarily true ever. So the ranking for these three upper bounds crucially depends on the substitutability coefficient. So here in vertical, I have the substitutability coefficient. In the horizontal line, we have the damage from pollution. Importantly, we have two main regions. Above as hat, we have the case of a strong substitutability, and below as hat, these two regions here is weak substitutability. So with strong substitutability, what happens is that the market power does not pay. So if agents regard the two goods, the brown and the green good, as highly substitutable, they regard them as very similar. So the market power in the cartel case or in the club case is not too important, but the important part will be the case of the green tech. So these green tech firms, they will attract, this green tech scenario will attract more green firms than the scenario with market power. However, if the substitutability coefficient is small, then the market power pays. And in this case, it is the green cartel which attract the highest number of green firms, both here and here. So in any case, the cartel always attract more green firms than the club. The reason being because in the cartel, no one internalizes the pollution. And that's why there are more green firms always in the cartel than in the club. As for these two regions, the difference lies in this case, the damage is very large. And because the club internalizes the damage, so the green tech attracts more green firms than the cartel. than the club. However, here the damage is so small that the club, even though the club internalizes the pollution, because the pollution is small, the club is able to attract more green film than the green technology, because in the case of a club, we have market power, and here we don't. So we have these three different cases, and actually this region depends on the parameters of the model. I will not go very much to these details, but just let me remind you that alpha green is the effectiveness of the green technology, and the higher is this effectiveness, the lower is this region 2A in favor of region 2B. Also, the higher is the region case 1. So I will focus on alpha green, because this is alpha green is the effectiveness, and we could think that the government is able to affect the effectiveness of the green technology if it subsidizes R&D in new green technology, for example. A similar thing can be applied to W. W is the cost disadvantage, and the government can also control the cost disadvantage. For example, if the government directly subsidizes green production, so this would reduce the cost of producing green. I'm not going through the details of this graph. Let me just move to the main results. As I said before, what I'm doing now, let me remind you, we're in the case of a mixed market. I'm trying to explain what is happening within this interval, but because we are comparing three different definitions, I will only state here the best one of the three. So the question that we try to answer now is which of the three definitions of being green is the best? So in case 1 with strong substitutability, it means that S is sufficiently large. Then what we observe is, let me first talk about an initial set of values, and then we will make this sensitivity analysis. In the initial set of parameters, well, because we have a strong substitutability, so the green tech attract the highest number of green films. However, the pollution stock is not the highest in the case with the highest number of green films. Interestingly, what matters here is not the number of green films, but the type of green films. In the case of the club, the films internalize the pollution, and then we could obtain a lower pollution stock than in the case of the green tech. As for the consumer surplus, it is always the highest in the case of the green technology. This is true for case 1 and the other 2 cases, and this is true no matter how we modify the parameters. Finally, the consumer surplus per unit of pollution, well, the best scenario is not the same for the whole interval. What this says is typically the consumer surplus per unit of pollution is the highest in the case of green tech, but this is true for most of this interval, but not at the beginning. At the beginning, the green line, which is the consumer surplus per unit of pollution, in the case of a club, is higher, is the highest. It's higher than the cartel or the green tech. So what this says is, look, if the premium price is small, then it is good in terms of consumer surplus per unit of pollution. It is good to have a club, but if the premium price is medium or large, then the best thing is to have green tech films. So this is the initial situation, but if the government subsidizes green production, if the cost is not so different between green and brown production, then the only thing that changes is the number of green films, and it only changes at the beginning. If the premium price is small, then it pays to have market power. If the premium price is small, then the largest number of green films is observed for the green club, so for the green cartel. In other cases, the highest number of green films is still for the green tech. And finally, if the effectiveness of the green technology is sufficiently large, then, well, the only thing that changes is the pollution stock. And this is interesting. What this says is, look, if the emissions per unit of pollution for the green firms is sufficiently small, this means that the green firms, they do not pollute that much. They just pollute very little. And if the green firms pollute very little, what matters is not the type, as we saw here, but what matters is the number. Actually, what matters is the number of brown films. And the number of brown films is the lowest precisely in the green tech. That's why here, what we have is what matters was the type, the club, and here what matters is the number of green films, which is the highest for the green tech. Actually, if we look at the last row here, this says that, look, if the effectiveness of the green technology is good, is very high, then just forget about the firms who internalize pollution. You would be better off with the green technology firms. So if we move from strong to weak substitutability, so we have mainly the same thing. The only difference is that now with the weak substitutability, then it pays to have market power, and therefore the definition which attracts the highest number of green firms is the Cartel. The rest is the same except for this cell here. Again, the lowest pollution stock is obtained in the case of a club, so the type of film matters. But here, what we said before is, you know, when alpha green is small enough, what should matter is the number. So here we should focus, we should have that the lowest pollution stock should be given by the Cartel, but this is not the case. Well, the reason is that if we reduce alpha green sufficiently, we no longer remain in case 2 with weak substitutability, but we go to the case 2b with even weaker substitutability. And in this case, we do have this number effect. What matters here is that there are very few brown films in the case of the Cartel, and that's why we have the smallest or the lowest amount of pollution in this case. On the rest of this table is similar to the others that we have seen, except for the consumer surplus per unit of pollution. Well, this is the same as before, but what this says is it is possible to see that for a low premium price, the club does better in terms of consumer surplus per unit of pollution, but not for large or medium premium price. Or it is possible that for the whole interval, we observe that the green technology gives us the best consumer surplus per unit of pollution. Unfortunately, I'm not able to interpret this last cell, so I will skip it because I don't know why we're having this strange result for very, very, very low alpha green. So let me just conclude what we have done. We have defined we have given 3 different definitions of what we understand by green films. In the case of green tech, we have cleaner but more expensive production technology. The Cartel, we have the same plus the market power. And finally, the club, we have the same market power, but also we have the deep films, they are environmentally concerned. In all these 3 situations, we are able to show that we have a stable equilibrium. And we see that if substitutability is not too high nor too low, then whether we are in the case of only brown, mixed market, or only green, basically depends on the premium price. If the premium price is small, is medium, or is large. So if we are in the case of only green, if the premium price is very large, then for pollution, the best option is the club, and the worst option is the green tech. But for the consumer surplus and the consumer surplus per unit of pollution, the best option is to have the green technology scenario. For the mixed market, let me just conclude. For the mixed market, the comparison is more cumbersome. I should focus on these four variables: the number of green films, the pollution stock, the consumer surplus, and the consumer surplus per unit of pollution. For the number of green films, as I said, the cartel always attract more than the club. But the largest would be the green tech in the case of a strong substitutability, the cartel in the case of weak substitutability. So depending on substitutability, we might have more green films without market power or with market power. For pollution, well, likewise as in the case of a green market, well, the lowest pollution is given by the club, except when the effectiveness of the green technology is very high. If the effectiveness of the green technology is very high, then we have to look at the number, not just the type of green that we have. And the number of green film is the highest when we have a strong substitutability for the green tech, or when we have weak substitutability for the cartel. So the green technology will provide the lowest pollution stock with strong substitutability, and the cartel with weak substitutability plus low environmental damage. The consumer surplus is always the lowest for the green tech, but the consumer surplus per unit of pollution, it is the lowest for green tech if the premium is not too small. But if the premium is small, then one would prefer the club, unless alpha is quite small, unless the effectiveness of the pollution stock is sufficiently high. Okay, I think that my time is up now. So thank you very much for your attention.